Okay, so proof number 2. All right, so per theorem 1, P and Q up to the order of their factors each have distinct prime factorizations. All right, so per theorem 1, fundamental theorem of arithmetic, which tells us that every natural number has a unique prime factorization. And we are taking the fundamental theorem of arithmetic as an axiom for this argument. And I have a footnote here, obviously, regarding this phrase, up to the order of their factors. So up to the order of the primes, which is a convention that you'll run into quite a bit in mathematics, higher mathematics. I'm linking to a stack exchange that was answered by Pete L. Clark, who's a mathematician at the University of Georgia, I believe. So the question was asked by this person, M.S. Kim, in 2013. How do I understand the meaning of the phrase up to in mathematics? And then the answer was offered by Mr. Clark, who, as I say, is at the University of Georgia in the Department of Mathematics. So we can certainly put some weight behind his answer to this question. I happen to think it's a really good sort of intuitive way of thinking about it. But yeah, if you want to become familiar with this phrasing, this idea, which you're going to run into quite a bit, he does a really good breakdown here. So generally speaking, when we use the phrase, we're saying X is true except for Y in some sense. Or in other words, X is true, but not strictly speaking correct, that X is true, and the Y, which occurs after the up to, clarifies the sense in which X is not quite true. So roughly, X is true except for Y. And he goes on to say that this is a phrase that's, somewhat freely used, potentially abused. When one says that integer factorizations are unique up to order, then it's understood that, of course, we could have, right, this sort of cycling over commutativity with respect to multiplication. And we don't want to count these as being essentially different factorizations. So we consider these individually to be unique, or we consider this to be a unique factorization up to these particular cycles over order, over commutativity. So probably not the best way of sort of expressing this idea, but hopefully that gives a little bit of intuition. So let's look into this. So p squared has this prime factorization. Okay, so we're assuming p is we're taking p and q to be respectively prime, mutually prime. And so what that means then is that p is going to have this prime factorization with n number of factors, and p squared just means multiplying p by itself, which gives us twice the amount of factors. The same factors, doubled, right? And we can look into this markup here. I'll just run through this quickly since yeah, we're doing all of these calculations or computations in the context of MathML, right? So the way I would write this, I'm going to use this tag m_, right? MathML underscore. So yeah, if we're doing MathML in this equation editor, as we know, we want to start with math tags. I'm just giving it a name, product of primes. You don't have to do that, but it helps sort of like flesh out the code stack a little bit such that it's readable or more readable. So we're going to have two tags or elements that are going to place something under something else. The first element gives us this nice underbrace right here. The second gives us the counter, the index on the factors. So, and then this accent under, I'll probably say more about that maybe later on in this video or maybe in a separate video, but this is basically allowing for this accent under true. I don't think if I experiment with this quickly, yeah, this equation editor happens to not really handle this case very well. But if you're coding this up in Whisk for the purposes of running a web page, these will change. This expression here sort of defines whether there's padding in these spaces right here. Okay, so we want a little bit of padding, basically. This is a good best practice, I guess, that I have it in here. All right, and so then we want to have a row. And this row is going to be the parenthesized quantity. All right, so parenthesized quantity, that's the name that I give it. Again, this naming scheme, you're going to be seeing quite a bit of, is that I'm always trying to stack my code in a block kind of way such that it's just legible, such that it's just easy on the eyes to read. So it's not always perfectly symmetric in terms. Well, it gets pretty good though, but it's not always going to be perfectly aligned, perfectly symmetric in terms of opening and closing tags. But the trade-off is that it's going to look blocky and it's going to be somewhat easier to read for me, and hopefully that'll be the case for you, and it might not be, so you just have to play around with that if you're watching this. All right, so we're going to have 1, 2, 3 factors with subscripts on them. So we have our opening tag for the row, parenthesized row. We have our opening parentheses right there. And this is our first factor right here. M sub, right, indicator. So subscript, indicator, the actual numerical subscript. And then the closing of that subscripted factor. And then second, you can use mid dot, you can spell it out the way I have here. Another way to get that symbol, it's not this guy, right? That's a sort of thick, that's a bullet. Okay, so mid dot and bullets are different. The way you get mid dot by way of keystroke or shortcut